Is a great question on regression analysis. One of those areas that normally disturbs students, not your normal regression. You know, at times your examiner is very, very lenient. He will give you like a column X, column Y, and then he'll tell you to get the regression coefficients. You get, in this case here, the slope B, and then you get A using those formulas. I know that one, all of us are comfortable. Whenever in this case here, your examiner wants to push you straight away to the far ends, what he will do, he will give you this kind of a question. Yeah, so we are told here, the following regression equation was obtained for a class of 24 intermediate level students. So we have here y with a hat. Yeah, y with a hat. So we're given here y with a hat is 4.3. 4.3, we have here plus 0.029 x1 plus 0.017 x3. And then they have given us what we call the standard errors. They have given us what we call the standard errors. So the standard errors, we have the standard error for predictor 1, which is 0.074. This, no, have I written all of them? No. It's supposed to be 0.029 x1 plus 0. Now, can you kindly read for me what you have on the papers there? Because I can see there's a repetition here. I doubt whether it is true. I can see a repetition here, 0.029 x2 plus 0.0173 x3. Can somebody in this case here check for me this one or this one? One of them must be wrong. x2 is wrong. So what should I write before x2? What should I write before x2? Oh, all of them are correct. All of them are correct like that, eh? Because I can see a repetition here and this one here. Chances are, can somebody confirm that both of them have a coefficient of 0.029? Thank you so much. So then we have in this case here, standard error for this one is 0.04. Standard error for this one is 0.013. Standard error for this one is 0.007, like that. Where y with the hat, students score on a theory examination. X1, students rank from the bottom in high school. X2, students' verbal aptitude score. X3, a measure of student character. So they want us to calculate the T ratio and the 95% confidence interval for the independent variables X1, X2, and X3. Very easy. We start by giving them the T ratio. How do we get the T ratio? So solution. So number one, T ratio. So to get this T ratio, you basically take the coefficient itself. You divide it by the standard error. Standard error. That's how we get T ratio. To get T ratio, you take the coefficient all over the standard error provided. So this is the first thing they have asked us. Number two, they have told us to give them the 95% confidence interval. 95% confidence interval, write the two formulas first. So how do we get the 95% confidence interval? Remember, confidence interval must have a lower limit and an upper limit. Must have a lower limit and an upper limit. So then, ladies and gentlemen, how do we get this confidence interval? It's normally very easy. To get this one, I will take the coefficient itself. To get lower boundary and upper boundary, I use here plus or minus. Then here, I could either use Z or T. Either use Z or T. Here, I shall use the T statistic because I'm handling small sample. Remember, whenever n is less than 30, whenever n is less than 30, then this becomes a small sample. This becomes a small sample. And for all small samples, you use T statistic. You use T statistic. If it's a full large population, if it's a population where n now is more than or equal to 30, once it touches 30 and above, it becomes a population, a large sample. Yeah, a large sample. Large samples, you normally use Z-score. This question, you can see they have told us how many people are in this research. They have told us the following regression equation was obtained for a class of 24 intermediate level students. There are only 24. 24 is less than 30. And if 24 is less than 30, then that will be called what here? A small sample. A small sample. And for small samples, we use T statistic. So up to here, ladies and gentlemen, are we really clear? And have you taken your small note? I would want us to go slowly because we're only doing 2 questions anyway. It's clear, great. So in this case here, T times the standard error. T times SE. SE, in this case here, is standard error, like this. Standard error. Standard error. So then we start with the X1. So now we are getting, in this case here, T ratio for X1. We get T ratio for X1. Remember, the examiner doesn't want T ratio for the constant. That's why he has not given you standard error for the constant. He wants T ratio for the predictor variables. Yeah, for the predictor or independent variables. So we get T ratio for X1. So X1, I'm using this formula. The coefficient for X1 is 0.029. That is the coefficient. The number that comes before X1 is the coefficient, like the gradient. We divide this by its corresponding standard error. This is the standard error. You divide this by its corresponding standard error. So is there somebody who is able to give me this T ratio? Anybody who is able to give me this T ratio? 0.029. You divide this by 0.074. Give me an answer. Yeah, according to Cheruyot, we are getting 0.0391. You have to be very, very careful. LC is giving us 3.9. So I don't know who is telling me the truth. I would want in this case here to get another opinion. Until I get like 2 or 3 students having the same answer, that is when I will be confident. So Christabel is confirming. Remember, you are taking 0.029 divided by 0.074, isn't it? But I think the correct answer should be 0 point something, isn't it? Just use your calculator. Use your calculator. Or the standard error is 0.0. Or there are 2 zeros in between. Sorry. There are 2 zeros in between. That is where the problem is. There are 2 zeros, I'm sorry. There are 2 zeros, I'm sorry. There are 2 zeros, I'm sorry. So then the correct figure should be 3.9. 3.919. We always work out our figures to 3 decimal places. Thanks for that correction. So is this number okay? Is this number okay? Is it okay now? Thank you so much. Great. So then after that, what I will do, I will go to T ratio of X2. Please give me the T ratio of X2. Give me the T ratio of X2. Go ahead and give me the T ratio of X2. Give me the T ratio of X2. So T ratio for X2, the model is very easy. You take the coefficient, the number that comes before this, you divide this by 0.013. I don't want to make a mistake. Yeah, this is 0.013. This I'm right. So this one I'm being given by Calvin, 2.231. 2.231. Can somebody else confirm? Can somebody else confirm? I'm always comfortable when I get like 2 or 3. Yeah, thank you so much. Somebody has confirmed. Then go and give us the T ratio. Give us the T ratio for X3. So for X3, what do we have? We have 0.0173 divided by 0.007. I hope you're right there. 0.07. 0.07. So this gives us 2.429. This gives us 2.429. So now we have the T ratios. for the three variables. And remember, the higher the t ratio, the stronger a regressand is. The higher the t ratio, the stronger an independent variable is in terms of research plausibility. So in this case here, the very best independent variable will be x1. You can see x1 has the highest, isn't it? x1 has the highest. x1 has the highest. So if that is clear, ladies and gentlemen, then straight away I will be able to take you to the next concept still under part 1 of this question, where now they want us to give them the 95% confidence interval. 95% confidence interval. So we have here 95% confidence interval. CI stands for confidence interval. Remember, we are using the t statistic here. The t statistic. The t statistic. Remember that all confidence intervals are two-tailed tests. All confidence intervals are two-tailed tests. So in this case here, we have our two-tail. So if we are doing 95% confidence interval in between here, then we have our significance, level of significance. So the level of significance, the level of significance will be 5%, because this and this must always add up to 100%. Level of significance is what we denote like that. Remember, if, for example, let me ask you a question. If the confidence interval was 90%, then the level of significance would have been what percentage? Yeah, 10, because they are complementary. They are complementary, you must be very, very careful with that. They are complementary, you must be very, very careful with that. They are complementary, you must be very, very careful with that. So I'm repeating, they want us to give them a 95% confidence interval, and 5% is here. So if this has been able to take care of 95%, then outside, what we call the level of significance will be the difference, 5%. And because there are two tails, each tail will take half of this. Each tail will take a half of this. So remember that this is 0.05 divided by 2. So 0.05 divided by 2, that will give us what figure? 0.05 divided by 2 will give us what figure? 0.05 divided by 2 will give us what figure? Use your calculator. So this means we have 0.025. So this tail will be 0.025. This one will as well be 0.025. And then, of course, now in between here, we have the 95%. We shall have accounted for 100%. The key thing is you to understand how we are getting the tails, and to understand that all confidence intervals, you may confuse about other areas, but we shall never confuse confidence intervals. They always have how many tails? It's a dog with two tails. Confidence interval is a dog with two. That must be a funny dog with the two tails. So up to here, ladies and gentlemen, are we together up to here? Are we together really up to here? Are we together really up to here? Are we together somehow? Somehow, Lucy is saying yes. It's only one student who is saying yes, unfortunately. At least Hillary has been able to see. Yeah. So the take home, thank you very much. The take home here is that all confidence intervals, I'm going to teach you about the one tail test, and don't get worried because there are no three tails, eh? There are no three tails. You know, the students, I've taught for so long these papers, here at RCM and at universities. So you start teaching this, so you tell them there is one tail, two tail. Then another person will just put up their hand. They'll ask you, fine, now I've understood one tail, I've understood two tails. Is there a possibility that in future you shall learn about three tails? No. It is either one or two. And because now we are doing a confidence interval question, we are quite clear in our minds that all confidence interval questions have how many tails? They have two tails. That shall never, ever, ever confuse you. Now, ladies and gentlemen, so from there now we go and read our t-tables value. So our t tables value from the tables, because we'll be given t tables, we know in this case here that we have one tail. Remember, you normally use one tail now. So the t tables, we are using 0.025 with a v. V will be equal to 24 minus 1. 24 minus 1. What does this v stand for? This v stands for degrees of freedom. Degrees of freedom. V stands for degrees of freedom. And how do we get degrees of freedom? We normally take the sample size minus 1, especially when you are getting hypothesis of one predictor variable. You're not doing one at a time. You're not doing a whole. You're not doing Y24, good question. It's given in the question. We are told here, perhaps you haven't gotten the question, yeah. We are told here the following regression equation was obtained for a class of 24 intermediate students. Yeah, do you have the question really? Yeah, so the sample size is 24. 24. All right, Sid, thank you very much. Thank you very much. Yeah, you see now, yeah, for asking a question, you have assisted Lucy. That is why you should always ask questions. Always ask questions. Always ask questions. Yeah. You know, when you are looking at degrees of freedom for a whole equation, then I would have said the concept of n minus k. But you see here, we are only testing one estimate. So we'll have lost what we call 1 degree of freedom. 1 degree of freedom. So then these will be 24 minus 1. So 24 minus 1, that gives me 23. So can you then get out your t tables? Please get out your t tables. Do you have them from the back of your past papers? From the back of your past papers? From the back of your past papers? So you should be able to read the t tables up there, the title. Don't use the z table. Don't use the z table. Don't use the normal distribution table. No, we are looking for the student t. This was discovered by a student like yourselves. Don't use the chi-square. Don't use the chi-square. Students normally confuse. There is a t distribution table here. Do you have this t distribution? You go to where it's written there, t.025, because you're using 0.25, So you go to t.025, and then you walk around. Yeah, until you see 23. Anybody who is able to read for me until you see 23? Anybody who is able to see the t.025 until you read? You know, we have degrees of freedom column here. So you're walking down until we see 23. Anybody seeing 2.07 something? 2.074, just check. Because you're reading t.025 with 23 degrees of freedom. With 23 degrees of freedom. That hesitations will automatically mean that students don't have the table. It could be that students don't have the table. So the t tables, therefore, the t tables, I'll be able to move very slowly here. The t tables value is 2.0, 2.0, yeah, 2.074. 2.074, like that. Study is saying it 2.069. 2.069 actually. You're right. I'm wrong. You're right. 2.069. How I wish it could be many students who are able to get that figure. Thanks, Carl. Christabel, Christopher, Cheriot. I haven't seen you guys giving me a figure. Brian Abdul, this man with a great suit on a red tie. No, red tie is really good. Yeah. I haven't seen you giving me a figure there. T table. We're using the T table. We're using the T table. Can somebody share that table on WhatsApp? Is there somebody who is able to share that table on WhatsApp? Like Christabel doesn't have that table. It's at the back of your past papers. Yeah, somebody should be able to help me. Yeah, you know, you read the one that is given on your table. Like now my table has, you take it in full, the one that is given as it is given in your table. My table has just these three. Else yours I've seen, yours has more, isn't it? So you take the way you have it in the table provided by the examiner. Don't say that Dr. Aura told us to be using 3 decimal places. No, they are figures which are normally given by your examiner. You shall be able to adopt the way they are. I would want Christabel to be comfortable. I would want Christabel to tell me that Mwalimu have gotten the table and she has been able to read it. Yeah, Hillary also wants this table. Shared on WhatsApp. Thank you, Sarah. You are so nice. I think today you should get my... No. I'm not giving that present that easily. Brian, it has already been shared. Check. It has already been shared. Check. Check, and then we read together. Check, and then we read together. Yeah, if you look at the table that I have here, they have only shaded one side. They have only shaded one side. And you see now, you know the whole thing has 2 tails. But you see now they are guiding you how to read the table. In their case, to read the table, they're only using this one side, which is 0.025. 0.025. They will always guide you how to use the table. All right. So having gotten that, ladies and gentlemen, then everything now becomes quite simple. How does it become simple? Because I know how to do the 95% confidence interval. So to get this 95% confidence interval, my good students, we will always take the coefficient itself plus or minus t. It's normally z or t, depending on the sample size. So you're using the t times the standard error. So we start with x1. What is the coefficient of x1? It is this one, 0.029. All right. So 0.029 is the coefficient plus or minus the t table, the one that you have read. The t table, the one that you have read. The one that you guys have read, which I've rubbed, unfortunately, but I can also pick it from here. Yeah, it was 2.069. So plus or minus 2.069 times the standard error for x1. The standard error for x1 is 0.074, like that. So you give us the lower limit and the upper limit. So lower limit is obtained when you subtract. So lower limit, you will take 0.029 minus this times this. You give me an answer. Yeah, I'll be able to repeat. So in this case here, lower limit, you take 0.029 minus this times this. Give me an answer there. So somebody is asking where the table has been shared. We have a paid group. There is a paid group for QA. Those students who are at RCM, we have a paid group. That is why we have shared. And I would want to invite all the students, ladies and gentlemen, who are not yet at RCM to join us, like almost immediately. Yeah, how do you join us? You simply pay these offer fees of 1,500. Yeah, for the revision. Yeah, 1,500. And once you pay this 1,500, then you'll be able to get the revision, Zoom revision classes. Yeah, very, very good. Like what you're doing now here. And then, of course, you'll be able to get our 12 prediction videos. They're very good. They normally help. They're not going, we're not saying that they will come, but they normally help. And I hope the students who are in the paid group have already started watching those videos. They are very, very important. Yeah, because they're our predictions. All right, as a school, we normally try. Yeah, we may not get, at times even we get 0. But trust you me, once you watch all those 12 videos, you can't get out of it with nothing. No, not possible. Not possible. So then that will really be able to help you. So if you're interested in this program, you simply give us a shout at 0793 555 000, and we shall be able to put you up into this program. Where are the 12 videos? Oh, okay. I'll be able to get somebody to really take you through. I can see you guys are not really being given all the materials that are supposed to be given to all RCM students. I need to be in charge now. So lower limit we are subtracting and Christabel is giving me. Yeah, Christabel is giving me 0.013 something. 0.014. 3 decimal places. That's lower limit. Please give me the upper limit and then I'll be able to answer Lucy. The upper limit. The upper limit, now you get the upper limit by adding. So 0.029 plus 2.069 times 0.0074. What figure are we getting? 0.0. Thank you so much, Austin. 0.0. 44. 0.044. Thank you very much. Thank you very much. So then those students who have understood what Mwalimu has done, can we kindly go ahead and do for X2 and X3 as I explained how to read this table to my great daughter called Lucy. Called Lucy. All right. All right. So I hope in this case somebody has been able to understand this. And if that is the case, go ahead and give me the lower limit for X2, upper limit for X2 like that. So Lucy, this is what we did. To be able to read the T tables is normally very easy. To read the T tables is normally very easy, very, very easy. So data requirements, what do we need? Data requirements. So number one, we need the alpha over 2 because these are two tails. These are two tails. If it has a negative, you put negative there. You put negative there. It's possible for it to be negative. So alpha, remember our confidence interval plus alpha must always be equal to 1. The confidence interval that we have is 0.95. It's 95%. Plus our alpha here, then this should be equal to 1. Meaning that our alpha will be 1 minus 0.95, which will be 0.05. Alpha, remember, is level of significance. Alpha is level of significance. So then come and divide this. So this will be 0.05 divided by 2, which somebody gave me 0.025. So up to here, Lucy, are we together? So the first data requirement is alpha over 2. Number 2, Mandela free. Mandela is free. We need number 2, what we call the degrees of freedom. Degrees of freedom. What we shall be abbreviating as V. What we shall be abbreviating as V. So these degrees of freedom, to get them, we use n minus 1. We use n minus 1. So degrees of freedom, we shall use what we call n minus who? N minus 1 to get them. N is the sample size. In the question there, they have given us the sample size. In the question here, they have given us the sample size. They have given us the sample size. Oh yes, they've given me the sample size as 24. The class has 24 students, just like this class of ours, which today has 28, but this one here has 24. This one here has 24. This one here has 24. So, ladies and gentlemen, then with 24, how do we get these degrees of freedom? To get degrees of freedom, we take n minus 1. Don't ask me where 1 is coming from. It's part of an equation. So n is 24 minus 1, that gives me 23. And then now what you will do, you see, if you look at your T table, they have given you here many T's. They have given you T.1, T.05. Go to where it is written T.025, which is 0.0 now. So you walk around with this. And then we have degrees of freedom. Degrees of freedom here, they are 23. So you walk here, you'll be able to read here, which is 2 point something, which is now 2 point something, whatever. So I don't know whether Lucy have been able to reach there. Can somebody remind me this figure? It is supposed to be 2.069. 2.069. It could be more in your table. Could be more in your table. Ah, great. Then now we can go to X2. So then how do we get, ladies and gentlemen, how do we get, in this case here, the confidence interval for X2? Oh, very easy. Very easy. So confidence interval. So confidence interval for X2, we take the coefficient for X2, 0.029 plus or minus the T tables. The two T tables is 2.069. So we have here 2.069 times the standard error. The standard error for this one is here 0.013. And then I should be able to give me, ladies and gentlemen, the upper limit and the lower. Start with the lower. Start with the lower limit. So lower limit you're subtracting. So you take this minus this. You say 0.029 minus, let me write here for your revision. So 0.029 minus 2.069 times 0.013. So this one here for X2 gave you what figure, ladies and gentlemen? This one here gave you what figure, ladies and gentlemen? We are overcoming, we are thriving, we shall thrive, we shall overcome. We shall overcome. So this one here gives us what figure? Ah, it is already 8. We have a 0.02. 0.02. 0.002. Thank you so much. And then we have the upper limit. So upper limit, what do we have? We are adding plus 2.069, 0.13, which will end up in this case here giving us what figure? Thanks, Carl, for giving me the lower limit. Now I want the upper limit, 0.056. Can somebody confirm these figures? Someone else confirm these figures. It's important for us to have the figures confirmed. Very, very important for us to have these figures confirmed. We are overcoming. We shall overcome. Thank you so much, already confirmed. And now I believe you can do X3 for me. I don't have to waste time now. Now you guys are experts, isn't it? Now you guys are experts. Is that okay? Now you guys are experts there. Yeah, thank you so much. Now, ladies and gentlemen, from there we can now go to number 3 of this question. So this question number 3, they want us to test the hypothesis of, if you look at number 3, in writing up a final regression, explain whether one should keep the last regressor in the equation or drop it. In the equation or drop it. This X3. So basically, number 3, do a significance test. So number 3, we are doing a significance test. So do a significance test. Do a significance test, also known as hypothesis test. Hypothesis test of a single coefficient. A hypothesis test of a single coefficient. So if it's a hypothesis test, so we shall start by putting down our hypothesis for testing. So of course, H0, we call this one here the null hypothesis. Null means not good, not good. So the null hypothesis, we are saying that the coefficient of X3 is not significant. The coefficient of X3 is not significant. Yeah, it's not significant. And then now we have the alternative, which will be the opposite of this. So the opposite of this, we are saying that the coefficient of X3, the coefficient of X3 is significant. By writing this, automatically you get a mark. Automatically you get a mark. So long as you remember H0, use the word note. Yeah, use the word there, note. So the coefficient of X3 is not significant. H1, the coefficient of X3 is significant. Now, when I write my hypothesis like this, when I'm now carrying out my hypothesis, will this be a two-tail test or a one-tail test? It will be two-tail. Two. Yeah, it will be two tails. Two tails. Why two tails? Because you see, either way, if it's very, very small, yeah, if it's very, very small, it will not be. You know, when it is one tail test, we'll write like this. For example, U is greater than maybe 30. U is the mean. This becomes one tail, bigger tail to the right. Or U is less than 30, one tail on the left. But when we write like this, not means either way, either way. Either way. So you have to be very, very careful, ladies and gentlemen. Either. So here, this is not a unidirectional. When it's unidirectional is when we talk about one tail. But whenever you hear the word not, you know that straight away, it's a two-tail test. And if it's a two-tail test, so we shall be able to come here and draw our tails. Let's draw our two tails. Like that. And remember, we are reading this, which we are very, very lucky because already we have been able to read. Already we have been able to read. We read up the 95%, 23 degrees of freedom. We read up there. So already we have this, which is 2.0, 2.0 something. It was 2, please remind me, I don't have to open my table. 2.0. Yeah. Please, Christabel, read the question. In writing up a final regression, explain whether one should keep the last regressor, which is X3. It's in the question. It's in the question. Read the question. 2.069. And then this is minus 2.069. Like that. So remember, one will be positive, the other one will be negative. Roman 3. We are now doing Roman 3. We are doing Roman 3. It's written here. Roman 3. We are doing Roman 3. It reads, in writing up a final regression, explain whether one should keep the last regressor X3 in the equation or drop it. So let's continue. So we have here 2.069. And then we have negative 2.069, negative 2.069. Now, ladies and gentlemen, after you have done this one, this is called the t-tables value. T-tables value. So after you have done t-tables, then straight away now go to the last step, which is the t-calculated. The t-calculated. So you go to the last step, which is the t-calculated. T-calculated. So somebody should be able to assist me answering somebody like Christabel there. We have finished already number 2. We have finished number 2. Oh, we haven't done number 2. I'm the one who has skipped. I'm the one who has skipped, but I discussed this when I was doing Roman 1, but no problem. So Roman 2, ladies and gentlemen, we finished Roman 3 first. I'll be able to go back there. Somebody should be able to try and answer Christabel. There are questions that you guys should be able to answer for me. All right. Ladies and gentlemen, what do we have here? So what we have, ladies and gentlemen, is the t calculated now. The t calculated for X3. For X3. So for X3, t calculated is coefficient over the standard error. Yeah. The coefficient for X3 is is 0.017. So 0.017 divided by the standard error. The standard error is 0.07. So 3 decimal places, what do we have here? Yeah, 3 decimal places, so what do we have here? 3 decimal places, so what do we have here? 0.0. Yeah, there should always be 3 chariot. Always there shall be 3 decimal places. Not 2. There shall always be 3 decimal places. Not 2. 2.429. Thank you very much. 0.429. Ladies and gentlemen, remember this empty space. The empty space here is for the null. No brains there. The empty space is for null. So remember, this is the H0. This is the H1 because of the significance. And this is H1 because it's shaded area. So the whole unshaded area is H0. The whole unshaded area is H0. Anything shaded is H1. So you've been able to calculate our T, and we have gotten this 2.429. So where do we put where do you locate 2.429? Remember, in between here you have a 0, eh? At the middle you have a 0. So where is 2.429? Where is 2.429? Is it in the shaded area or unshaded? Unshaded or shaded? Where is 2.429? Shaded or unshaded? Thank you, Christabel. Shaded, isn't it? So you say this is in the shaded area. In shaded area, and therefore, we reject H0. It is in the shaded area. It is in the shaded area, the H1 area. It is in the shaded area. It is in the shaded area. What you are calling, let me write here. It is in the shaded area. It is in the shaded area. In this case here, the H1 area. H1 area. And therefore, we reject the null hypothesis. The null hypothesis. The null hypothesis. That's how you must always make reference to the null, right? So it is in H1. So you're now portraying the broader picture. We are rejecting the null hypothesis. And when we reject the null hypothesis, we are saying that this X3 is not useless. So we reject the null hypothesis and conclude that, that X3 is statistically significant. Is statistically significant. Thank you very much. Thank you very much. Thank you very much. So if it is, so we read the question again. In writing up a final regression, explain whether one should keep the last regressor in the equation or drop it. Can you kindly, in this case here now, advise me? Should we keep it or should we drop it? Should we keep it or should we drop it? Should we keep it or should we drop it? Keep it. You write in the capital letters down there. So keep independent variable X3 in the model. Keep independent variable X3 in the model. In the model. To answer Christabel, I'd already explained this Roman 2. Determine the regressor which gives the strongest evidence of being statistically discernible. Being statistically discernible. So we said this one will always be given by the size of the T ratio. The one that has got the highest T ratio. The one with the highest T ratio is the one that is statistically great for us, which is X1. Which is X1. Ladies and gentlemen, remember again, QA, you are not going to do this QA exam with perfectionism. No. These kind of questions, if you just try them a little bit, you are able to get T there. We normally award all the marks because we know that this is one of the areas that disturb students. Even me, I got to know this, to be very honest with you. I got to know about these T ratios and, when I was doing my PhD, because this is research. So how do you expect a student who is just joining CPA, who has a long way to go to PhD to know these things? So for this area, you don't have to understand everything. But you see, again, we can't mark an empty script. So we expect you at least to know, how do we read this from this table? What am I going to write? At the end of the day, these kind of questions are marked this exam severally. So long as you have shown some significant efforts, then we shall be able to give you all the marks. And I believe with whatever you've done, If you present this kind of a case, then we'll be able to get all the marks. So is that okay, ladies and gentlemen? Have you gotten some exposure out of whatever you've done for confidence intervals? Have you gotten some exposure? It can't be 100%. Have you gotten some exposure? Yes, that is really important. That is really important. And with your permission, I don't know why I took long time here, because now I want to do, but I can leave this example with you. Yeah, like this question that was tested in August 2023. August 2023, question number 7B. August 2023, question number 7B. August 2023, question number 7B. August 2023. August 2023. Question number 7B. Single mean tests. Single mean tests. Single mean test. Not two mean tests, but just a single mean test. Very, very easy. Very, very easy. Single mean test. Single mean test. Single mean test. Is there somebody who has been able to get that question? And if you get it, are you able to take a screenshot and share with these ninjas in the group? Share with these ninjas in the group. Share with these ninjas in the group. Next time I know what I'll be doing, I'll be sending these questions to your group. Yeah, before our class. Actually, I'll be doing it like a day to like now tomorrow's questions, the ones that I'll be doing tomorrow, I'll ensure that I share them tonight. So they also don't waste time in searching for them. Yeah, so remember H0 basically is a null. Is in a zero dimensional null, null hypothesis. You simply say, the way the question was asked to you, that this, if it's x3, is not significant. Just as easy as that. And then in this case here, the alternative. I'm so sure you have done this topic in class, Christabel. You know, I'm here to revise. Have you done this topic in class? Have you done it? Have you done it? Have you done it? Have you done this topic in class? Me, I'm here to revise. I'm here to revise. Because of time, you know, I have very few sessions with you. Like now, there are students who have said, Mwalimu, you can't teach QA 5 times a week. We also need you here. So we are going to be doing this thrice. Thrice, I'll be able to give you a timetable. So those are 3 hours. So 3 hours I'm here to revise. And that is why I'll be sharing these questions with you in advance so that you guys can refer to your notes. All right. So consider the following. They haven't told me whether they have gotten the question. Have they gotten the question? Have they gotten the question? And for the new students who would want to join RCM, please don't hesitate. Come and get exposure to these great lectures. But I'm assuming wherever you've been studying, you have also finished your syllabus. Wherever you've been studying, you've finished your syllabus, you're coming here for revision. So for this revision, we have a great offer for you of 1,500. You call us today. We give you 3-hour sessions in a week to the exam. Like thrice to the exam. Those are live lectures. And then now we give you also what we call 12 videos. 12 videos you'll be able to provide also to the other students immediately after this. Great. So now that they haven't gotten this question, I beg that we stop there, and then we shall be able to start, because our 1 hour is over, we shall be able to do this single mean test when we meet tomorrow in the evening. So it has been lovely meeting you in the morning. See you later, and I hope you have enjoyed our short session. Thank you and bye. Okay, April 2025. first page. Okay, great. Bye. We shall overcome.